Thank you for tuning in. Innocent MAPANDA is my name. We want to attack this question. This is psychogeometry extracted from Zimsec, November 2012, paper 1. It reads, in the diagram, ABCD is a circle center O. AOB is equals to 80 degrees. AB is equals to BC. So this information is very important. AB is equals to BC. It shows that A, B, and C is an isosceles triangle. So isosceles triangle is a triangle with two equal sides and two base angles which are also equal. Right, so it means angle at C is equal to angle at A. I hope you are following. Let's move on. Part A, calculate angle ACB. So angle ACB, they want you to calculate this angle here. This angle is the required. So according to psychogeometry theorems, we all know that angle at the center is twice angle at the circumference. So it means I'm going to divide this 80 degrees at the center by 2. 80 degrees divided by 2, it gives me 40 degrees. So it simply means that we have 40 degrees at C. So I'm going to write 40 degrees here at C. So since C and A are equal, it also means that we have 40 degrees at A here, since C and A are base angles of isosceles. We move on to part B. Calculate angle ADC. ADC. They want you to calculate this angle here. Right. Another theorem from psychogeometry, it says that opposite angles in a cyclic quad, they add up to 180 degrees. So what is a cyclic quad? A cyclic quad is a shape with 4 sides and all the 4 vertices of that shape lying on the circle. So you can clearly notice that angle D, angle A, angle B, and angle C, all the 4 angles, they are lying on the circumference of the circle, which qualifies ABCD to be referred to as the cyclic quad. So to find angle at D, you first of all calculate the angle at B here. Since we now have 2 known angles in the triangle ABC, sum of angles in a triangle adds up to 180 degrees. So you are now saying 40 plus 40, it gives you 80. So to find B, you are saying 180 degrees minus 80 degrees. 80 is the total of 40 at C and 40 at A. You get 100 degrees. So it means angle at B is 100 degrees. But this is not the required angle, but it is going to lead us to the required angle. So you can clearly notice that this 100 degrees here is opposite to the required angle at D. And opposite angles in a cyclic quad, they add up to 180 degrees. So to find angle at D, you are now saying 180 degrees less 100 degrees at B, you get 80 degrees. I hope you are following. So we have 80 degrees here at D. We move on to part C. Calculate OAC. Where is OAC? Right. So OAC is referring to this small angle here. Let me put 3 arcs here. This is OAC. Right. So to find OAC, you need to calculate this angle OAB, which covers the required small angle together with the 40 degrees below. How do you find that angle? You can clearly notice that OAB is also as an isosceles triangle in the fact that from O to A, this is a radius. From O to B, this is a radius. So it means OA and OB are equal sides making OAB an isosceles triangle. So I'm going to less 80 degrees from 180 first. 180 degrees minus 80 degrees, you get 100 degrees. Then divide this by 2, it gives you 50 degrees. So it means we have 50 degrees here, and we have another 50 degrees here. So I'm going to deduct 40 degrees from 50 degrees to find this required angle, OAC. So OAC is equals to 50 degrees minus 40 degrees, which gives you 10 degrees. So I'm now writing down my answers here. The first one is 40 degrees. Angle at the center is twice that on the circumference. And the second one is 80 degrees. Opposite angles in a cyclic quad add up to 180 degrees. And lastly, we have 10 degrees.